So here's a problem where I'm going to show you how to use the normal distribution on your calculator. So it tells us in the problem that the number of visitors is normally distributed with a mean of 5,000, standard deviation of 750. So in order to calculate the probability that the number of visitors on a randomly chosen day in June is more than 400, I'm going to write out my probability inequality. So probability that x is more than 400, x is greater than 400, 4,000, I'm sorry. So now we're going to call up the calculator and go to second vars, and this time we want normal CDF. Again, if it's an inequality, we do CDF. If it's exactly looking for one number, we do PDF. So now the lower bound, if my inequality says x is greater than 4,000, then that means 4,000 is the lowest number, because I want everything above that. So now I'm going to type in a bunch of 9s to represent infinity. Okay, then the mean, this u means the mean, which in the problem is given as 5,000. So I enter in 5,000, enter, and then this sigma is the standard deviation, which is 750. Now I'm going to paste this into my home screen and hit enter, and I get 0.909 if I round to 3 sig figs. Okay, the second part, part B, calculate the expected number of days in June where the number of visitors will be less than 4,000. So now we need to reverse this inequality and do less than 4,000. So going back to my normal distribution, normal CDF, and now I want the lower bound to be negative infinity. So I'm going to type in a bunch of 9s, and the upper bound is 4,000. The mean and standard deviation are still the same. So now this probability is 0.0912 if I do 3 sig figs. I'm going to write that number down. 0.0912. Okay, and so to answer the question though, it says the expected number of days. So we're doing expected value. How many days in June are going to have the visitors less than 4,000? So we need to know how many days are there in June. I think it's 30. So we have to multiply this by how many ever days are in that month. So 0.0912 times 30, I can just say answer times 30. And so we would expect about 2.7 days. Depending on how we are going to round this, maybe about 3 days in June where the visitors are going to be less than 4,000. So approximately 3 days would be the answer. And you'd get a point for showing the probability also that we calculated. Now on the last one, we're going to use the inverse normal function. So on a randomly chosen day in June, the probability that the number of visitors is less than n people is 0.25. So it's going to be helpful to look at a normal curve here. And you'll know it's inverse normal because they give you the probability, but they don't give you the value of n. So if here's my mean, and they tell me some percentage is 25%, that's about maybe this much of the curve is 0.25. And then I don't know where this happens. I don't know this value. So I'm trying to find that value. So this is what we do. And I messed this up. It says the number of visitors is less than n people. So that's actually down here because we go left to right. So this is actually 0.25, and this is n. Now, let's go ahead and calculate. Bring up the normal distribution. And we want second vars, and now instead of normal CDF or PDF, we want inverse norm. Okay, now the area is the probability, that 0.25. The mean is the same mean we had before, which was 5,000, I believe. And the standard deviation was 750. Okay, and now the tail is, we want this to be left because it said less than 0.25. And so If it was the situation on the right where it said greater than, then we would want to change this to be right. So now I'm going to go paste, enter, and I get 4494. So that's the number of people. It represents the number of visitors. So we could reinterpret this and say the probability that the number of visitors is less than 4494 is equal to 0.25. So the probability that there are fewer than 4,494 people is 25%. So that's how you use normal CDF and inverse norm.